Good day, ladies and gentlemen, and welcome to your Emerging Energy Technologies Waste to Energy webinar. All lines have been placed on a listen-only mode, and the floor will be open for your questions and comments following the presentation. If you would like to submit a question at any time during the webinar, you may use the chat box located on the lower right-hand side of your screen. Simply type your message into the box and click on the send button. If you should require assistance throughout the conference, please press *0 on your telephone keypad to reach a live operator. At this time, it is my pleasure to turn the floor over to your host, Ben Hush. Sir, the floor is yours.
Thank you very much. Hello, everyone, and good afternoon. My name is Ben Hush, and I am the Committee Director for the National Conference of State Legislatures, Natural Resources, and Infrastructure Committee. I'd like to welcome everyone to today's webinar on emerging energy technologies, hosted by NCSL's Natural Resources and Infrastructure Committee. As a reminder, today's webinar is the fourth in our six-part series of e-learning webinars. Recordings of our first three webinars on the 2013 Farm Bill, alternative fuel vehicles, and the Restore Act can be found on our website at www.ncsl.org. But back to the task at hand. Today's webinar will focus on the emerging energy technology of waste to energy. Waste to energy is a process that takes municipal solid waste and uses it to generate electricity. While the process has been in existence for over 25 years, numerous countries have recently begun to rely more heavily on waste to energy. Today's webinar will feature three great presenters who will help us try and answer the question of what does the emergence of this energy technology offer states from both an energy supply and environmental perspective. We will be holding a Q&A session after all of our speakers have presented. As a reminder, you may type questions into the Q&A chat box in the right-hand side of your screen at any time during the webinar. With that, I am pleased to introduce our first speaker, Susan Thornlow. Susan is a senior chemical engineer with the Office of Research and Development at the United States Environmental Protection Agency. Susan has been with EPA for 29 years and has been responsible for more than 130 EPA publications. She has led the application of life cycle assessment in providing a more holistic approach to environmental management. With that, the floor is yours, Susan.
All right, thank you very much. Well, today what I'm going to talk about, and I will show my slides, is to talk about sustainability. And when we're talking about sustainability, energy is obviously tied to that. And we live in a resource-constrained world, and policy decisions result in social, economic, and environmental trade-offs. And in a recent World Bank report, solid waste was identified as the most important municipal service and serves as a prerequisite for other municipal actions. And so when we talk about sustainability, what that means is that we're trying to use and reuse materials in the most productive and sustainable method across the entire life cycle. And the sustainability, and we refer to this as SMM, but Sustainable Materials Management, and so it conserves resources, reduces waste, slows climate change, and minimizes the environmental impacts of the materials we use. And we have just launched, as of May of this year, the Municipal Solid Waste Decision Support Tool that helps you identify more holistic and sustainable solutions for managing materials once they enter the waste stream. And so the whole idea here is to get the best environmental benefit at the least cost for the materials that are in municipal solid waste. And it's one thing to talk about it, and it's another to quantify it, and that's why this tool is important. And so I'm going to talk about the tool and then how it's been applied in looking at energy from waste, including waste to energy. And this next figure is just showing you the life cycle, and it's really important when you're thinking about what makes the most sense that you look at the entire life cycle and you're not just thinking of end of life, because there's steps, like when we recycle or you recover energy from waste, then you're being able to offset fossil fuels, and it just really helps us in terms of finding strategies that are more cost-effective as well as provides more environmental benefit. And this next figure just shows you what the current status is in the United States, and this is in million tons, metric tons, but as you can see, most of our waste has all been going towards landfills, and that continues to be the case. And so this is looking at 1960 to 2010, and so we definitely have increased how much we're recovering for recycling. Combustion with energy recovery has grown, but not as much as some would like, because when you start seeing the potential benefits, you need to capture that. And that's what the tools that I'm going to talk more about allows us to do. And then it shows how much of this material also goes to composting. And so this next figure looks at the municipal solid waste composition before and after materials recovery. And so what I'm, I've got a pointer. And so this is, so we're currently at 230 million tons. And I just wanted to point out that's an EPA number, but BioCycle reports that we're at 350. And so how that material is managed is really important in terms of just how much it costs, what kind of environmental benefit. Are we really maximizing the energy from our waste? And so obviously this is before recovery, and then this is after. And so it's really important to look at what the discards are, and is it more beneficial to when you're starting to look at discards, you're either going to be landfilling or waste to energy. And so if you have like food waste here, and a lot of food waste does go into landfills, it will actually produce the emissions in just a few years, and a lot of landfills don't have controls in place yet, and so those emissions are just escaping into the atmosphere. And so the Municipal Solid Waste Decision Support Tool that I mentioned a couple slides earlier was launched this year. This is a website that you can go to. All of our documentation is available at the very end of this presentation. I have a list of all the different journal publications and documentation associated with all the process models that look at waste from the point of collection all the way to final disposal and obviously considering offsets. And so it allows you to compare your current practices and then look at new strategies, but looking at the cost, energy, and life cycle environmental trade-offs. And so the tool itself has defaults embedded, but you can override those, and you can look at, it's got multiple sectors, so you can look at residential separate from suburban and let's get that pointer again, and versus suburban, urban, and rural, because, when you've got houses, the population density is really important. And so if you're in real rural areas, sometimes having a recycling rate at 40% may or may not make sense. And so you really have to look at the population density and energy. What kind of energy are they transporting? And so this tool allows you to look at all those things. And so when you're making policies that affect how you manage those materials, then you want to make sure you're getting the environmental benefit, and you want to understand the cost. And so this tool allows you to do that. And so it has optimization capability in it, and so it allows you to look at the optimal solution with respect to cost or environmental emissions. And so you could optimize on energy, waste diversion targets, or even greenhouse gas, as well as criteria pollutants. And then we always include sensitivity and uncertainty analysis. Well, these are the system boundaries for the tool, and it's this collection, and you can, I won't go into that. And then this flow diagram has been pointed out. I'm a chemical engineer, and so what this is looking at a material and energy balance around waste. And when people think about life cycle assessment, they think about a product, and they haven't really thought about looking at across municipal solid waste. But that is what we've done, and so it allows you to set policies that are more effective in terms of maximizing the benefits and minimizing the burdens. And so obviously if you're like with waste energy, we're able to recover energy. So therefore, we consider offsets associated with either fossil fuels that are being displaced or ferrous and non-ferrous metals that are recovered. All right. And we have a Sustainable and Healthy Communities research program now in the Office of Research and Development. And so this tool is being used in Durham, North Carolina. And so it's going to be looking at separate collection of food waste and other organics, which is something that a lot of communities are interested in. They're thinking about an anaerobic digester, and they want to see how that compares to the other options. We're also looking at combining their waste with other communities to look at more regional solutions, and then also looking at sending the waste to a waste-to-energy facility versus landfilling. Currently, just about quite all discards are being landfilled. And then they also want to look at some of these newer technologies that are being heavily marketed in a lot of places, but aren't necessarily better when you compare to conventional technology and technology that's more proven in terms of municipal solid waste management. And in 2009, we did a publication that compared discards management options. So we're not talking about not recycling. It's just what do you do with the materials left after you've recovered and recycled what you can. And so we looked at a range of conditions for the U.S., what we find for waste to energy. There's much less variability in calculating emissions. We've got data on 100% of the facilities across the country. We have multi-pollutant, multi-year data. It's just we really have very good data for waste energy, and also the design and operation is very similar. In contrast to landfill gas, which you can also recover energy, landfills are just a much more difficult air pollution source to model. It's a biological process. There's many variables that change over time. There's just major data gaps. We've got less than 5% of all the landfills that we have data on, so we really don't have the quality and quantity of data on landfills like we do on waste energy. But there's a lot more landfills than there are waste energy plants. And there's just a lot more variability that we see in the design and operation of landfills in contrast to waste to energy. And so what we found when we did the comparison is that per ton of waste to energy is on average 6 to 11 times more efficient at recovering energy from waste than landfills. And part of that is because with waste to energy you get more ferrous, you get more metals recovery, and the other thing is that with landfills you always have some level of methane emissions because you don't, when you're placing waste in a landfill, you can't collect and control it the very instant it's placed there. And so the way our air rules in the United States work, you can have up to 5 years before you have to collect and control. So there's certainly emissions, and a lot of times people will look at it simplistically and think, oh, it's always at 90%, but landfills are, once you place that waste in a landfill, you have emissions for many, many decades, whereas with waste energy, you're processing it, you turn off the process, your emissions cease, whereas landfills, it's always producing emissions for many decades from waste placement. And so anyway, we also found that in comparison to landfills, that waste energy was better in terms of carbon per megawatt hour. And we've got this a publication if you want more information. This is the last thing on that paper I wanted to say, which is looking at what we did was we compared the carbon emissions per megawatt hour and looking across the different types of conventional electricity generating technologies, and this only reflects the emissions. It doesn't include any offsets. But as you can see, we've just no offsets. Remember that. But it's waste energy. When we compared it, it's quite different. It seems to be much better in terms of clean electricity production, in terms of fewer impacts to the environment. And then we did a review of the state of practice of these newer technologies. I mean, they're not new technologies. These have been around for a while, but they're new to us in the United States in regards to their application to municipal solid waste. And so this report uses that decision support tool that I referred to that allows us to compare these technologies to conventional technologies such as waste to energy, where you've got a much more proven track record, and the performance has been established. A lot of times this is only for specific components, so it can't be for all materials. And so anyway, this report goes into way more detail than I have time and probably you have interest in hearing about today. And but there's a database of planned and operational facilities, and so it's to give people credible, objective information so that they can look, and here's the link to it online. And then we've also looking at tipping points that influence energy and greenhouse gas emissions. And so communities, we're trying to do things more sustainably, but what is our best choice? And so we're looking at studies that have already been conducted and looking at what we can say based on these types of factors. Population density, as I've mentioned, that's quite important. Landfill gas collection efficiency is important. Just the local infrastructure. So anyway, that work is not completed, but check back, and we hope to have some recommendations based on U.S. operations. And then just to summarize, the decision support tool helps support broader goals to move towards more sustainable materials management. And so it helps you identify more efficient waste management options in terms of energy, environmental, and then some of the social aspects, such as land usage. And then it provides the data needed to benchmark your current operations and then to identify improved environmental performance. And then it also provides communities the data that they can use to communicate to the public about the performance of what is currently occurring and what may be improved in the future as newer technology or changes are made. And it's been used in over 100 studies. We've got lots of publications. The last few pages have those publications. And then if you're interested in a copy of the tool, it's available for free. RTI is the caretaker or the custodian of the Municipal Solid Waste Decision Support Tool. So just contact Keith Whites, and he'll send you a copy of it, or you can call me at any time. And then this is just I just did put some select publications. This publication I did in 2007, and it compares the different options, and that's a nice way. It looks at rail hauling, and then this is the publication I was showing you some slides from. Is it better to burn or bury waste for clean electricity production? And then if there's any of you that are interested in the nitty-gritty guts behind the tool, we have very thorough documentation, and you're welcome to any of that. It's all available on the project website. And I thank you for your attention, and as I understand, we're going to have questions at the end. Thank you very much.
Thank you, Susan. That was extremely informative. And I'd just like to remind everyone listening, we will make the slides available after the fact. So if you weren't able to jot down some of those studies or Susan's contact information, we'll definitely post these slides very early next week. If you need them sooner, please, you can email me directly at ben.husch@ncsl.org, and I can go ahead and send them out to you. But once again, thank you, Susan. I'd now like to introduce our second speaker, Richard Caperton. Richard is the Managing Director of Energy at the Center for American Progress. In this role, he leads the Energy Opportunity Team's work on renewable energy finance, electricity markets, and clean energy infrastructure. His work focuses on designing tools that will encourage private investment in clean energy. Richard has testified in front of the U.S. House of Representatives and is regularly quoted in the press on these issues. With that, Richard, the floor is yours.
Ben, thanks a lot, and thanks for having me. Susan, thanks for that presentation. That really reminded me of why the Center for American Progress is interested in waste to energy, especially your last bit there about is it better to burn or bury waste? And clearly your findings at the EPA are that we need to reduce our waste and then recycle and compost some, and then what's left we need to use for energy sources. So that's exciting, and thanks for that introduction. For those of you who don't know, the Center for American Progress is a nonpartisan think tank in Washington, D.C. We work across basically every issue that you could imagine, but on the energy team, we're tightly focused on clean energy development and deployment and fighting climate change. And we're excited about waste to energy because it is a clean energy resource that has the same benefits of every other renewable energy resource, that it's better for the environment and that it has great local economic implications as well. So I want to talk a little bit about those things today. I'm going to talk about the practical and policy implications of waste to energy, talk a little bit about the local benefits and the state benefits that you can take advantage of, and finally the tools that some states are using to enable waste to energy as a significant part of their energy mix and of their waste management mix. So first, I think this isn't going to be news to everybody, but anecdotally, we all understand that Congress isn't really leading at the national level, but this just puts a number to that and shows the declining activity in Congress and shows that there are opportunities that states need to pick up the slack here, and states are doing that. That's the good news, but we're really looking for states to lead on energy and environment issues. And climate issues and environment issues aren't going away. They are clearly there for states to lead on, and it's really important to have your action on this. This is just a quote from President Obama a few months ago talking about why climate change is so important. Now, he backed this up with what's called the President's Climate Action Plan. This was released, I think, on June 25th. And there's a lot of stuff in there, but I want to highlight two things that are really important for waste to energy. The first is the Environmental Protection Agency's coming rules on limiting greenhouse gas pollution from power plants, both on new and existing power plants. Now, those limits are going to be unveiled or rolled out over the coming years. That is a slow-moving process in some ways, but also it requires getting to work right now. So I want to talk a little bit about the role that waste energy can play in that. And the second part of the Climate Action Plan that really matters for waste to energy is developing this methane strategy and finding all the different ways that we can reduce methane emissions across the country. Methane, so this slide just talks a little bit about what I'm going to talk about. The two things at the bottom, reducing methane emissions and reducing greenhouse gas emissions, are directly related to the Climate Action Plan. But then there are things like just providing baseload clean electricity is valuable for our economy. Then there are the opportunities for investment and the various income streams that make waste energy a reasonable and good investment, the local benefits, and then finally a little bit on how states can take advantage of this. So let me start with the second of those two items from the Climate Action Plan, methane. Susan talked about this some. This pie chart shows that where the methane emissions in the United States come from. Now, methane, as you probably know, is different from carbon dioxide as a greenhouse gas pollutant. It's much stronger, much more powerful, but it's also shorter-lived, and it comes from different places. It's a different type of gas than carbon dioxide. Because it's so powerful, it's really critical that we take advantage of every opportunity out there to reduce it. And it turns out that landfills are a huge source of methane emissions. They're the third biggest source, 17% of our methane emissions, and waste to energy is a way to deal with that. Now, what's important is that waste energy is a better way of dealing with that than landfill gas to energy. Susan talked about this some, and I've got this inverted pyramid that Susan also had in there. What I like about this is that a few months ago, the former baseball player and I guess sort of disgraced baseball player Jose Canseco tweeted out his effective solution for climate change was reduce, reuse, recycle. And everybody sort of laughed at that as like, he doesn't have any idea what climate change is all about. And he may not, but it actually turns out that his solution works in the context of methane and waste to energy, that we do need to reduce and reuse our waste. We need to recycle what's left from that. And then what's left, what doesn't meet the Jose Canseco dealing with climate change strategy, we need to use for waste to energy. So we can just add that onto what he thinks we should do. Then there's also, on top of the methane stuff or beyond the methane stuff, is the Environmental Protection Agency rules on power plants and greenhouse gas emissions. So just a little bit of background here. The power sector is a huge source of carbon dioxide in the U.S. economy, about 40% of such pollution in the U.S., and the Clean Air Act allows the EPA, in fact, the Supreme Court has said that because of EPA research that EPA has to limit greenhouse gas pollution from power plants. And it's going to do this under something called Section 111D of the Clean Air Act. Now, the President has told the EPA to work with states in finding the right way to do this under Section 111D. And the EPA is going to be in touch with all of your states, probably through your state air offices, but through other parts of the government as well, including the legislature and the Public Utility Commission probably. And you need to find flexible ways to achieve deep reductions in greenhouse gas pollution. And the good news here is that waste to energy is a cost-effective way to reduce power or greenhouse gas pollution in the power sector, and it's a baseload power source. So unlike, say, solar or wind energy, this actually looks to the power grid a lot more like coal-fired electricity or electricity from a natural gas power plant. And people are already doing greenhouse gas emission reductions through waste to energy and selling those reductions. There's 2 facilities in Florida producing carbon offset credits for the voluntary market. And it would be beneficial to have every state in the country doing more with waste to energy and using waste to energy as a compliance tool under the Clean Air Act. Now, when you're building a waste to energy facility, there are a few things to keep in mind. The first 2 mean that these facilities are very attractive to financiers. The capital costs are clear. You basically know upfront what it's going to cost to build it. And the technology is well known. There are a lot of these facilities. Unfortunately, not as many facilities as there are landfills, but a good number of waste to energy facilities across the country. It gets a little tricky with the third item here, which is that they create 3 separate revenue streams. Now, the good news is having 3 ways to earn money is fantastic. The bad news is that they all sort of balance against each other, and you have to accurately predict what each of those revenue streams look like. So the first is that you contract with the municipality to secure the waste stream. That's what's called the tipping fee, and municipalities already pay the tipping fee to put the waste in a landfill. So they're used to paying that, and those tipping fees are knowable. The second is the income received from utilities for generating electricity. You just sell the power onto the local grid or sell it to the local utility. You can do that either through the spot market, which has some price risk, or you can do it through direct contracts, bilateral contracts, long-term contracts that are much easier to finance around. And the third, and I assume, I'm almost positive the smallest revenue stream is selling the scrap metal collected from the post-combusted ash stream. So there is going to be some waste left over, and you can sell it and make some money from doing that. So those are the ways that it makes money, and just a little bit about how you finance these. Now, when you build a waste-to-energy facility, you get some great local benefits. The first is that waste-to-energy is much better for waste management than landfills. It's just a cleaner resource. The second is that you get these greenhouse gas emissions, which ultimately will reduce the impact of extreme weather and climate change on your communities. And next is something that we don't think, it's a little bit counterintuitive, but it's that communities with waste-to-energy technology have an aggregate recycling rate about the national average. That means that this isn't eating into recycling, which is the common criticism of waste-to-energy. In fact, I think what it shows is that communities that have a comprehensive approach to waste management are still doing all the recycling, and then they're just landfilling less. So it looks like waste-to-energy eats into landfills and not into recycling. So that's a fantastic good news story. Now, finally, there are states that are taking advantage of waste energy, but the resource is not spread evenly across the country, and there are some reasons for that, and it's because some states have policies that enable this technology and other states don't. So Connecticut, for instance, had a bunch of landfills in violation of state and federal law and realized they needed to do something about it. So they developed a comprehensive plan to transition to waste to energy. And now because of that, because they took it seriously, they have the highest percentage of waste going to waste energy facilities in the country. And then a more specific example of this is in Maryland, where they have a renewable energy standard, just like 28 other states, 29 states total, plus the District of Columbia have a renewable energy standard. And Maryland's had two tiers. So there's a Tier 1 technology and Tier 2. By upping waste to energy from Tier 2 to Tier 1 and making it more of a core resource, they up the amount of waste that's being burned for energy instead of going to landfills. And that's good. That puts it on even footing with other energy resources that deliver very similar benefits. So finally, just to remind you again, taking advantage of waste-to-energy technology creates high-paying jobs in local communities. It keeps money within your community, generates baseload renewable energy, and gives your state, not just local communities, but gives your state a way to comply with relevant federal laws. So it's an important resource that every state needs to consider and every state needs to take care of. We have written about this. My colleague Matt Casper has written a report called Energy from Waste Can Help Curb Greenhouse Gas Emissions. It's available on our website at americanprogress.org, and it delves more deeply into all of these points that I mentioned. Also, we're certainly going to take questions at the end of this call, but I'm always happy to respond to any questions. This is my email address. That's also my Twitter handle at Richard Caperton. Feel free to get in touch anyway, and always happy to talk with state folks about these things. So, Ben, thank you for organizing this call, and look forward to the rest of the conversation.
Thank you, Richard. That was very helpful and a great presentation. I'd like to now, moving on, introduce our third and final speaker, Markus Glies from Germany's Federal Environment Agency, who has kindly agreed to spend part of his Friday night with us to discuss the European and German experiences with modern waste management concepts. With that, Markus, the floor is yours.
Thanks so much, and thanks to Susan and Richard. And I hope I can give you some of German and European experiences on this question, because we did much on waste management during the last 30 years, and even I'm involved nearly 30 years in this question. We'll a little bit focus on the question of thermal treatment of waste, especially of waste incineration, because this is my special profession in our agency. But it's still part of the European and even the German concept of waste management, and there are different reasons why we could so precisely inside this question. It's even also, as Richard said, you can recover materials from waste, and it's even the question of greenhouse gases, and this is combined with the question of safer landfill. We have seen this before, just turned around, but this waste hierarchy, which seems to someone more than a theoretical approach, is still part of the European Waste Ordinance, and all the projects on waste management had to look very precisely on this pyramid. It's a little bit easier to go to the part recovery and disposal. Recycling is more complicated, and even reuse is the most complicated ways. Prevention is a question often of social behavior and not so much of techniques. This is a very interesting slide because it shows that the European Union is a little bit different. If you look directly on waste management, you can find Germany, Netherlands, Belgium as the countries with the highest incineration rate, but even also the highest recovery rate, and a very small rate of landfill, nearly none in Germany. And at the other hand, you have, we call it more the eastern part and the southern part of the European Union, where you have nearly, if you look, for example, at Romania or Poland, nearly 100% of landfilling. But we also look very precisely on other neighbors which are not joining the European Union, like Switzerland or Norway, even also industrial countries, which do it in the same way as you can find in the Netherlands or in Germany, a high rate of incineration combined with a high rate of recovery. Just to have an imagination where you will find most of the waste incineration plants, it's more in the middle part of the European countries, and you don't find, a little bit problematic with the pointer, you don't find so much in the eastern part. This all started from the question how we can get a safer way of landfilling, and we worked on this question nearly 30 years in Germany. And first we tried to do something to prevent emissions to water or to air, and then we recognized that we had to change the waste which is going to landfills, and we started with this here called pre-treatment technologies. As this time, Green Party was part of the authority which was responsible for these things. For this reason, you don't find only incineration, but you find a special way of Germany, so-called mechanical biological treatment, where you tried by mechanical and biological methods to reduce the organic compound in the waste which was going to landfill. At the other hand, we also had some more standards for landfills. We have an EU directive, and this allows many countries to go more stricter on the question of landfill. As you find, for example, in Germany since June 2005, untreated household waste is no longer allowed to be landfilled. You had to reach a very small amount of organic compounds in the waste to go to a landfill. Other countries like Austria, Netherlands, for example, they have landfill taxes to make it more expensive using a landfill, and for this reason you are not far away from the prices of a waste incinerator, for example. This is a little bit going back in the history of waste management in Germany during the last 30 years. We started at identifying the main problems to be solved, especially on the question of landfills. This was the question how to protect soil, service groundwater, and to reduce the methane emissions. Even the question how to handle with the volume, because this is the difference to the United States, especially when you look for Germany or the Netherlands. We have not so much space to put waste, for example, in the desert. Therefore, we need also the space, and this is the reason why we look more precisely on technical solutions. And the first act handling with this question started in 1986, and even at this time, we made both. We started to increase recovery and recycling, and we set some more higher standards for the treatment and for the landfilling. We had a special ordinance or some special technical instructions on the question of landfilling over a period for more than 10 years. And when we noticed that this does not go to the direction of reducing or banning landfill, we made an ordinance which no longer allows the landfilling of organic compounds, and for this reason we have gone to technologies like incineration and mechanical biological treatment. Here are just some pictures to show that this is reality. Here you have some recovery in this part. The pointer, yes, I think it's happened. This is for recovery. This is a typical waste incineration plant. This is composting, and this is the MBT plant where we also have digestion. Just a short overview what happens to incineration during the last more than 20 years, nearly 50 years. We started with a relative small amount of incinerators in 1965, but we have a tradition for waste incineration more than 100 years, because the first one worked in Hamburg in 1896. Therefore, there is a relative long tradition of waste incineration in Germany. And we ended up with a total capacity at the moment of about 19 million tons per year. This is a capacity of special household waste incinerators. We also have about 25 specialized incinerators for RDF, which are mostly located directly to industrial areas like chemical industry or paper mills, to offer the electrical power and the steam or the heat directly to this area. This is a short overview from 2007, just to have an imagination how much waste is generated in Germany. And my presentation was mostly dealing now with the municipal waste. We have also a huge amount of construction waste, but this is not so a problem on the question of the organic compounds. And by the question organic compounds, you have also to look very precisely what happens with the municipal waste volumes in your country. And as we heard from the presentations before, we also look very precisely on the question of organic waste, just to have a chance to use, for example, composting, but now for the future more the technique of digestion to get even a gas out of the organic waste, which can be used for energy production. But when you look a little bit more precisely on the question of electricity and heat, you will find that municipal waste incinerators are the technique which is able to produce most of electricity and heat. And even in comparison with the need of electricity and heat in Germany, we are able to produce about 3.6% of the electrical consumption in Germany, and even 2.2% of the thermal heat consumption in Germany by the use of waste incinerators. And this also has a relevance to the climate, as we heard from Richard and even from Susan. And when you look especially on the question, what happens if you are able to reduce your greenhouse, especially the methane emissions from landfills, then you can see how much we were able to reduce the greenhouse effects of waste management by reducing the organic material which is landfilled, and especially after we have a ban of landfill for municipal waste, we reached a point which is nearly not so far away from nothing. And we did some calculations on the question how much you can influence greenhouse gas emissions by a better system of waste management. And also in this slide, you can see that you have a main impact by incineration, by co-incineration, but you also have a main impact by recycling, by using paper, glass, and something other materials, because you are able to reduce the energy consumption during the production of these materials. Coming back to the system of management of municipal solid waste in Germany, you will find a very wide combination of different techniques, beginning with sorting plants, the idea of ADF power plants, a normal thermal treatment, and even the biological mechanical treatment plants, which offers you a different system of techniques for using waste. And you still find a little bit like the dumping sites, but this is a relative low amount of the total waste, and it's especially, for example, filter dust from the gas cleaning of waste incinerators, which is typically dumped in Germany in underground facilities in salt mines. And coming to the end, a little bit more a view on thermal treatment. You can see that especially parts of the waste streams where you have main problems to get more recovered material outside came to the thermal treatment process. Normally it's waste incineration in Germany, and you can offer energy from this process, but even resources. And Richard mentioned the question of scrap metals. This is more wealthy than we also thought, and we looked very precisely on the colleagues in Switzerland, which even found silver and gold in this stream. And we still started on Thursday a special research project in Germany to get out more, especially non-iron metals from the slag and the ash of waste incinerators. Just an imagination on the question how a waste incinerator looked like. It's a little bit more than a fire on the horizon. It's a relatively complicated technical solution to burn waste, to get energy by steam, to produce electrical energy, and even if you look a little bit more precisely on the question what's happening with the flue gas, you will find a very sophisticated flue gas treatment system to reduce all the toxic elements in the flue gas. I think if you look here as an example of a gas cleaning system, it's one idea. Here's a wet scrubber system. You also find some dry scrubber systems. They are a little bit more not so expensive like the wet scrubbers, but just to have an idea how much is done during the last 30 years to reduce emissions from waste incineration plants. And this is just a table which summarizes what is done in the year 2000 to 2003 in the European Union. We worked on a paper, Best Available Technology or a Technique for Air Emission Standards in Europe for Waste Incinerators, and it's more than 300 pages describing very precisely how a well-fitted incinerator can be used for waste incineration. And we still are starting in the next year to update this on the European level, and I'm still started with this program on national level in summer of this year. Let me summarize a little bit about thermal waste treatment, some conclusions, and it might be not so interesting for all these people laughing not laughing about, I laugh a little bit about gasification and pyrolysis. We had the experiences, and you will find it at the end of this slide, that we have much losses on these technologies during the last 30 years. And for this reason, we looked more and more precisely on the typical waste incinerators for municipal waste using roller crates, and we still tried to do some better equipment for the energy efficiency, especially if you look at the combination of heat and power processes, and even we looked very precisely on metal recovery from slag and ash. I think the gasification and pyrolysis from our point of view is no alternative method for mixed municipal waste. We have still some research projects on the question how to produce some gas from RDF by gasification, and even we have a project at the moment on pyrolysis of SLF from automobile shredders, but it does not work, we think, for the normal municipal waste. And thanks a lot, and even if you try to contact me, you will find my email address at the end of this slide. Thanks so much.
Thanks, Marcus. That was extremely informative. Obviously, there's a lot going on in Europe. And with that, I'd now like to open things up to the audience if anyone has any questions for our presenters. So, operator, if you would please begin the Q&A session.
Thank you. The floor is now open for questions. If you do have a question, please press *1 on your telephone keypad at this time. Questions will be taken in the order they were received. If you are using a speakerphone, we ask that while posing your question, you pick up your handset to provide favorable sound quality. If at any time your question has been answered, you can remove yourself from the queue by pressing 1. Again, ladies and gentlemen, if you do have a question or comment, please press *1 on your telephone keypad at this time. Please hold while we poll for questions.
Thank you. And while we're waiting for people to ask some questions, one question that we got, Marcus, during your presentation was if you could please speak a little bit more about the fees and taxes that are imposed on landfilling untreated waste in some of the locations in the EU, specifically how much are those landfill taxes or fees?
It's not so easy for me because Germany don't have landfill taxes. We prefer the landfill ban. As I learned from the colleagues in Austria, there is a fee which is about, I think, on $50 to $60 per ton. And by this, you come more and more to the same gate fee as you had to pay for an incinerator. And this is the idea. Not a strict ban like in Germany, but increasing taxes which are normally used then for research projects for recovery. There is a binding use in most of these countries for recovery or still for better solutions for incinerators.
Great, thanks. I believe there's one question in the queue. Operator?
Okay, and this question comes from Andrea Kilty. Please state your question.
Hi, thanks very much can you hear me?
Yes, I can hear you.
We're curious to know about what Germany's history is. The information that you provided about the waste management levels that you have today are very impressive, but how long has it taken Germany to get to those levels? Like, what was the waste to energy, recycling, and landfill split, say, 20 years ago?
A little bit more than 30 years.
More than 30 years?
Yes. To come to the level, I think we reached this level about 2006 to 2007, and even I started as a student at the beginning of the 80s, and at this time we turned much more in the direction of technical solutions, but even also in a very intensive discussion of recovery, and we especially started with waste recovery on the question of glass and of paper. You don't find so much of this material still in the normal municipal waste. Most of this is gone directly to recovery, but it took a longer time. You will not reach this from one moment to another because society must accept this, and it's now highly accepted in Germany. Someone in the European neighbor countries are still a little bit laughing about because it's like a little bit like religious for us to separate waste.
Thank you.
Okay, and there appear to be no more questions in the queue.
Sure. Then this is Ben again. We got a couple questions over the web during the presentations, and this question is actually for Susan and Richard. And it comes to us basically. The question boils down to that there is this expectation that EPA may be issuing some new rules next year on municipal solid waste, and just kind of how that may impact the incentives regarding waste to energy plants here in the U.S.
I mean, I'm not aware of a regulation for municipal solid waste. I'm aware of regulations that we're updating for landfills, and we've updated our landfills for other sources too. So I'm not clear. Maybe Ben, maybe Richard knows what the person's referring to.
I think I think you're talking about the same thing. I think specifically it deals with emissions from landfills.
Oh, now landfill, I can talk to you about that.
Okay.
So is the question, are we updating our landfill air rule?
I think more how that might impact the waste to energy, the incentives surrounding waste to energy rather than landfilling waste. How these new rules might impact that cost benefit analysis.
Just to be clear, I'm not on the policy side, so I can't really speak on the rules, but at the same time, whenever you're tightening up on the landfill regulations, and so that means that they're going to have more cost associated with making sure that they're minimizing the emissions from landfills, then that will make waste to energy more cost competitive. Richard?
So I don't know any. You should talk about any potential EPA regulations. I think you'll know more about that than me. I mean, the issue with taxes and tipping fees and financial incentives are all closely related, and they're all different levers that you can pull. I mean, in just the northeast of the United States, where we tend to do more waste to energy, the tipping fees range from a low of about $32 in Rhode Island up to about $100 in Maine. So there's a great variety in tipping fees, and anything that we could do to make people pay the full cost of putting trash in a landfill and letting it decompose and pollute the air and water over the years for a long time going forward is going to be beneficial to waste to energy. And like you talk about with potential regulations on landfills, again, anything we can do or anything that increases the cost and more fully reflects the actual cost of putting trash in a landfill is going to be beneficial to waste to energy.
And in fact, that's why I stress the decision support tool, is that when we're comparing costs from different options, we're looking at the full cost. We're not just looking at the landfill tipping fee, because that, as what Richard just said, that may or may not reflect the full costs associated with landfilling, looking at the emissions over time, over decades, and making sure that you're comparing apples and apples. And so that's what that decision support tool allows you to do.
Susan, we actually just got a question over the chat box, and it comes from Ross Gould. And the question basically asks that he has seen some studies from EPA that put waste to energy at a higher carbon and other pollutant emission levels than coal, whereas in your presentation you had a slide that showed that waste to energy is lower than coal. And he was just wondering if you were aware of those studies.
I'm not.
Or excuse me. Those studies were not from EPA. I apologize. Other studies. But if you were aware of those studies that had placed a higher level of emissions from waste to energy as compared to coal.
I would find that hard to believe because, comparing it to coal, I'm thinking landfill, sorry. But that is that's what we found in that, and that was published in Environmental Science and Technology. Ours is a life cycle, so they may have not taken into account extraction of coal, just looking at emissions per megawatt hour and not looking upstream and taking that life cycle approach. So I'd have to look at what they did to see how the numbers compare and to be able to explain it further.
Okay, great. Thank you. And seeing no other questions either in the phone queue or online, I'm going to go ahead and conclude today's webinar on emerging energy technologies. I'd once again like to thank Susan from the Environmental Protection Agency, Richard from the Center for American Progress, and Marcus from the German Federal Environment Agency for presenting today. For those of you that joined late, or for those that would like to listen again, NCSL will be posting a replay of today's webinar online early next week. Our e-learning webinar series continues next Friday, September 20th, where we will focus on the subject of food waste, specifically the issues and opportunities surrounding potential emerging partnerships. We look forward to seeing you all again next week. With that, thanks again for joining and have a great weekend. Thanks, everyone.
All right, thank you.
Thanks. Bye.
Thank you. This does conclude today's teleconference. We thank you for your participation. You may disconnect your lines at this time and have a great day.
Thank you.